Hello everybody. We are going to learn the power rule of differential equation in this particular video. Not much of an introduction or anything is required because power rule is the first and the most important differentiation rule that is applied throughout the mathematics of calculus and differentiation. So let us quickly go ahead with learning what are the rules of power and how do we calculate and use examples on this. So for the power rule, what I would like to show you is that what is the formula for using the power rule. So starting with the first part, it is written as d by dx, which contains any number raised to the power x to the power n, and this would be written as equal to, we will bring this down, so it would be n times x, and this would be less minus 1. So this is all. This is what we need to know. So we find the power of any number. So we use this part comes here and this goes 1 less, right? So now let us see some quick examples using this particular part. I will just use very trivial and very simple examples. Say for example, d by dx of x raised to the power 2. If we want to find the power rule of this using the power rule formula. So just note that what we do is that we bring this right in front, right? So we write 2, okay, right? Then we bring this as usual, we use this one, and then we subtract 1 from this. So we write 2 minus 1. So eventually what happens, what we get is 2x raised to the power 1. Let us see another example. What if we find the d by dx of x raised to the power 3? So we use this power rule, which is right in front of you on the top, this one. So what we will do here is that we will first bring this right at the front. So we'll write 3, right? Then we will write this part, which is x. Then we will take 1 less from here. So it would be 3 minus 1. And this would be 3x raised to the power 3 minus 1, 2. So that is how we are using the power rule. How do we solve d by dx of x raised to the power 4? So you can use yourself, or you can just use the same way. We write 4, right? And then we used to write x, and then we reduce this one to 4 minus 1. So eventually it becomes 4 equals to x raised to the power 3. So that is how it happens. But just note that we are using this d by dx term, which has been used previously explained in my video, which you can see in the description. I have given you the link if you want to know what is d by dx and what is the difference between d by dx and dy by dx. So when we are using d by dx of this entire term, remember that all of these cases, x4, x cube, x squared, whatever, these are all the y's which are given. So it is something like this. y equals to x raised to the power 4. What is the derivative using the power rule? So this is already assumed, right? So you can watch my video on d by dx. Things will be clearer. How do we solve y equals to 2x raised to the power 4? How do we find the derivative using the power rule? So what we do over here is that we use dy by dx, y because it's the y term involved in it, and we use the same power rule over here. So what we do is that we bring the 4 right in front because it is on the just in this way 4, and then we write this x, right? And then what we do is that we use this term 2 minus 1, so this one becomes 4x, right? Now how do we calculate the derivative of, say, y equals to 2x raised to the power 4? Note that we have a y term, so obviously what we will do is that we will calculate the dy by dx equals to, we will first bring this term right at the front, so it would be 4, and this one would be 2x, and this part will be reduced to 4 minus 1. So eventually the result that we get is 8x raised to the power 3. Now the second rule which comes into play is that, say for example, if you want to find a derivative of, say, d by dx of 5x, how do we find the derivative of this term? Now, just a point that you need to note over here, that whenever you're trying to find the derivative of 5, which is a constant, right? So we have a constant over here. So the constant rule tells that always the derivative of a constant is 1. Oh, I'm so sorry, the derivative of a constant is 0. So this is a general rule that derivative, let me write it for you, it would be easier. So a derivative of a constant, say for example if I use it as k, is always equals to 0. So in that case, if we go forward and we try to find out the say dy by dx of 8, so whatever it is, it will always be equals to 0. So this is a general rule, the derivative of a constant is always 0. Now say for example, okay, having said this, that the derivative of a constant is 0, say for example, if we get something like this, say if I am trying to find out the d by dx, the derivative of something, a number, right? And what we do over here, we write 1 multiplied by this number, and we reduce it as 1 minus 1. So what we get is 1 multiplied by x to the power raised to the power 0. Anything raised to the power 0 is 1. Right, so this is another nice example. So I will just show you what it is. So for example, we have to find the derivative of this particular number. So if I want to find out the derivative of, hope this is visible, d by dx of, say, 5x, say for example, yeah, so d by dx of 5x. So what we do over here, let me show with a different color. So when we solve this part comes right at the front, right? So we write it over here is 5, right? This part comes right at the front, and then we use d by dx, right, of x, because the derivative of x, which we have seen earlier, is 1. This part is 1, so the whole thing reduces to 5 multiplied by 1 equals to 5. Right, let me show you another example. So what if I want to find the d by dx of minus 7x? Right, so what if you want to find this one? So what we do is that this part becomes right in the front, so minus 7, and then x, the same one, is 1, and it becomes minus 7. So these are quite good examples which we can use in further. Okay, so considering that particular formula which we just learned, how do we find the d by dx of say 9x raised to the power 4? Okay, so let us try to solve this part. So what we do is that we are trying to bring, as we learned, 9 right at the beginning. So we write here 9, then we write d by dx, right? And then what we do is that we bring this part right at here. So we bring x raised to the power 4. And this part actually is what? When we bring this part right in the front. So from here we can just rearrange it. We write 9 and then we write this part right at the beginning, 4. Okay, x raised to the power 4 minus 1. So this becomes 36x raised to the power 3, right? So this is our answer. Similarly, if we want to proceed further and we want to take the derivative of d by dx of say 7, d by dx of 7 x raised to the power of 5. So how do we solve it? So what we do is that we take 7 right at the beginning. This part comes in the front and then we do the d by dx. Okay, so what eventually happens is there we take 7, then we take 5, this part comes over here, then we write the x, then this part is further reduced to 5 minus 1. So we get the answer as 35. X raised to the power 5 minus 1 is 4. Okay, so let us see another example. So how do we solve the d by dx of, say for example, a little bit longer one, 4x raised to the power 5 plus 7x raised to the power 3 minus 9x plus 5. So how do you find? So just remember, it is nothing difficult. What we need to do is that we need to find the derivative of each of these terms individually, right? So first what we do is that we take down this, right? So what we do is that we take 4, then we bring this at the front, then we reduced, I am not writing it again, so this was 5 minus 1 equals to 4. We then take this term further down, right? So this is 3 multiplied by 7, x raised to the power 3 minus 1, it's 2. Then we take this term, we have a minus sign, remember. This one is 1, so this becomes 1 plus the constant dy by dx of, by d by dx of any constant is 0, right? So what we get over here is 20 x raised to the power 4 plus 21 raised to the power x squared minus 9. So this gives our answer. So just remember that it is we have to be careful. We need to find out the derivative of each and every term individually. First, second, third, and the fourth. And we need to put the operators identically. So let us see another example. If I write it in this way, f of x, okay, equals to 6x raised to the power 3 minus 9x plus 4. So we will just follow what we have learned earlier. We will take the derivatives of each and every term. But when we are using this fx, I won't write again, say for example, dy by dx. Rather, I would use this sign. If you remember, if I'm not wrong, it is the f prime sign, which is Lagrange's sign. And we can use this. So what we do is that we bring 3, then we write x, 6, then we write x, 3 minus 1 is 2. Then we find 9x as usual, 9x raised to the power is 1 and the derivative of 4 is 0. So finally what we get, f prime of x equals to 18x raised to the power 2 minus 9, because 0 it is not required to write. following further, how do we solve this part? Say for example, if we're given y equals to, we use a different term this time, 2t raised to the power 4, right, minus 10t raised to the power 2 plus 13t. So similarly what we do is that we follow this rule. We take a step-by-step derivative of this. So if I take this down, so I can write this as 4 multiplied by 2, it would be 8. T, 4 minus 1, that would be 3. Then I put the minus sign. So this would be 10 multiplied by 2, 20. T, 2 minus 1 is 1, plus 13, and this one is always 1. So what we get over here is this. So further solving, we will get the values as 8t, 4 minus 1, 3, 20t, 2 minus 1 is 1, plus 13. So that gives our answer. Okay, so far so good. So what about, these were all the rational numbers, but what about if I want to find the d by dx of, say, root x, which is a radical number? So how do we find the derivative of this? So just note, when I will further expand this part, what I am going to do is that I'm going to write this. If you observe closely, then this can be further written as x raised to the power 1, right? And root 2 means it will be this part, right? So what is the rule for this? How do we do? So it is simple. So what we do, we take the d by dx, okay, and let us rewrite this as x raised to the power 1/2, right? So what we do is that with this, bring this one as usual, half, okay, x, and then we reduce 1/2 minus 1, and what we get is that, yeah, so this would be equal to 1 divided by 2x raised to the power 1/2. Now note that if I am going to solve this particular part, that is 1/2 x, this part, okay, so let me just show you in this way. This would be equal to 1/2, okay, x raised to the power minus half. Okay, now just note one thing, that when we are getting a kind of a negative sign, okay, we are making this negative sign go at the denominator and making a kind of a positive sign, right? So when we are getting negative sign, we will push it at the at over here from the top, right? From the top it goes down here and we get a positive sign. So this now can be rewritten as equals to, so this one as rewritten as 1 by 2 root x, which is the d by dx of this particular term, right? So I hope this becomes clearer to you. So how do we use the radicals in order to get the derivatives? So just remember that when we are using this 1/2 x, 1 minus 1/2, so 1 by, we are just using, we are bringing this below, okay, this, we are bringing this below and we are writing it as 1 by 2, and this becomes positive. So this is, I will show you another example so that things will become clear. So let us say, I will push this aside, fresh one. So for example, if I want to find the d by dx of this one, 7th root of x raised to the power 4. Let us see how we can solve this part out. So what we do is here is that we write d by dx, okay, x, we rewrite this one as x raised to the power 4 by 7, okay. Now from here what we do is that we write 4 by 7, okay, x raised to the power 4 by 7 minus of 1, minus 1. From here, we can write over here 4 by 7. Okay, I'm just writing from here. X raised to the power, this would be how much? Minus 3 by 7. This would be minus 3 by 7. Right? Now, when we get this minus 3 by 7, what we can do is that we can this bring down below. Okay, and what we do, we write like this. We take 4 on the top, and then we write 7x, and this because we are bringing it down, the denominator becomes a positive 1, right? And this can be rewritten as 4, and we put on our root over sign, so we get this as x cube 7. This would be 7, and we write 7th root over here, right? So with one more example, let me show you over here. So for example, this part, d by dx, we're trying to find out, okay, the third root of x raised to the power 4. So what we do, let me use a different color so that you understand. This one is, so d by dx, right, and then we rewrite this one as x 4 third minus 1, right? This we work out as this would become 4 by 3 x 1/3, this part. So now see that there is, because no negative sign, so we don't have to split things up. So just remember, for this radical functions or radical values, whenever it is right on the top, bring down at the bottom, right? And this becomes this one, and then you can rewrite it. Same goes with here. So if it is negative minus 3 by 7, we brought it down and we solved this. This one doesn't have any negative sign, so this makes things clear. Okay, just few quick more examples with power rule. So just to make a kind of a revision. So just note that if you've got a function f of x equals to x raised to the power anything, so obviously you can rewrite this as f prime of x equals to, this one would come right at the first, so x 10 minus 1 would be 9. So just remember that whenever you have a variable of a power, that powers come right at the beginning and then you minus it. Say for example, we get another expression, something like g of x equals to, say for example, we have got x raised to the power 5 upon 2 plus 3x plus 4, right? So we are trying to find the first derivative of this. So what I can do, I will use the Lagrange prime notation over here. So g prime of x, I can write this one as, we bring this one, so 5 by 2, we're following this rule, x raised to the power 5 by 2 minus 1. Then I use this one, right? So I use 3, and then I use 1x. So 1 minus 1 would obviously be 0, and the constant part is always 0, which we learned. So this can be rewritten as 5 over 2, and this we can solve as 3 by 2. Again, it's good that we don't have a negative sign. Plus 3, this would be 3, and 0 doesn't matter. So we get 5 over 2 x raised to the power 3 by 2 plus 3. So this is how we find the derivative, right? So let us see, for example, another example. So what if I want to find the d by dx of 5x raised to the power 6? So what we do is that we quickly bring things down. So 6 multiplied by 5 would be 30. X raised to the power 6 minus 1 is 5. So just write it, 6 minus 1, right? So a few more examples will make things clear. F of x equals to x raised to the power 3 plus 6x minus 8. So this time, although we don't know we haven't gone through the addition, this rule of summation difference, but we can just solve it like f of x equals to, this one will be 3x raised to the power 2, and this one would be just 6, and this one would be 0. So this would be the answer. Now say for example, I'll just give you something different, like something like this. Say, so if I get a kind of a, okay, this is another one. So if I get a kind of a, what I would say, the second derivative of x, and this one is 3 multiplied by 2 x1, say for example. So what I did, you just note, is that from here, this is the first derivative, and let me write it for you. This is the second derivative. So what we do is that we bring this 2 down, and then we get 6x1. So we get the second derivative as 6x. What about finding the third derivative? Yeah, we can do that. So f1, 2, 3, we find the derivative of x. So it would be the same like 6x. Okay, what about finding the third order derivative of this part? So constant, so it would be 0. So you see that we got the second order and the third order and the fourth order derivative. So I think that actually summarizes the entire part of what we have been learning. We have been going through power rule. So we have gone through quite a number of examples over here. We have seen how we can calculate the power rule. We have also used these particular equations where we learned how to use the radical functions, where just a quick note that if there is a negative, which you can bring right below so that it turns to be a positive one, which we have seen here. We have also seen this one, that is if you get a constant, this coefficient right in the beginning, so you bring this forward, and we showed certain examples like 7x5 and this one and this one. Also what we have seen is that how do we calculate, or what is basically the power rule, that we have seen it earlier. So we have seen this also, which contains the basic fundamental formula for power rule, and how do we calculated it, and how do we bring these things right at the front. And we remember the derivative of a constant is always 0. And so these are the things that we have done. These are quite useful formulas which you can use it further. And this is the way in which you are doing it. So you see that how things are being calculated. So you are bringing things right in the beginning. This is the same, this is the same. In the same way, these are all the same things, except the radicals that you need to be a little bit careful about, using the negative sign, bringing right at the denominator and making it positive. I hope this clears up a lot about power rule. So what we are going to do is that you can practice more and more, and if you have any questions, you can let me know. We're coming up with the next video, which is the product rule. Thank you very much. Do subscribe and like, and have a safe day ahead. Bye.